Any router supports static configuring NAT and an Internet FTP server. Before configuring NAT and an internal FTP server, let's go through how NAT ALG works. NAT converts IP addresses and port numbers at the IP layer. However, it cannot convert IP addresses and port numbers contained in application layer protocol packets, for example, FTP and DNS packets. As a result, such protocol packets cannot be forwarded. NAT ALG, short for Application Layer Gateway, converts address information contained in application layer protocol packets. It enables a NAT device to convert not only the IP addresses and port numbers at the IP layer, but also the IP addresses and port numbers contained in application layer protocol packets. In this example, an FTP server is deployed on a private network and connected to a public network to provide FTP services for public network users through a NAT-enabled NE40E. FTP is an application layer protocol that works on either active or passive mode. Based on network deployment, NAT ALG needs to be enabled in either of the following situations. An FTP server is deployed on a public network, and an FTP client is deployed on a private network. In this situation, the active mode is used for the client to access the server. An FTP server is deployed on a private network, and an FTP client is deployed on a public network. In this situation, the passive mode is used for the client to access the server. In this example, the NAT ALG function needs to be enabled only when an FTP client is configured to access an FTP server in passive mode. Next, let's look at the networking requirements of the NAT and an internal FTP server. As shown in the figure, the internal FTP server of the enterprise is connected to the Internet through NE40E to provide FTP services for external users. The IP address of the internal FTP server has a private IP prefix of 192.168.10.0 and the mask length of 24. The interface connecting NE40E to the public network is assigned a 24-bit public network address. The enterprise is assigned 5 public IP addresses. After the configuration, PCs with the internal IP prefix of 192.168.10.0 and the mask length of 24 can access the Internet, but PCs on the other network segments cannot. PCs on the Internet can access the FTP server inside the enterprise network. Here is the configuration roadmap. Step 1. Configure basic NAT functions. There are 2 substeps. 1. Create a simplified NAT instance. 2. Configure a NAT public address pool. Step 2. Configure an FTP server. Step 3. Enable the FTP ALG function. Step 4. Configure and apply a NAT traffic diversion policy. Next, let's go through the configuration on the device. Create a simplified NAT instance named NAT1. The service board is automatically bound to this NAT instance. Next, configure a simplified NAT address pool in the system view. The address pool contains 4 public IP addresses, 11.11.11.102 through 11.11.11.105. The public IP address, 11.11.11.101, is reserved for the FTP server. Next, configure an internal FTP server, assigning it to the reserved public IP address 11.11.11.101 and the private IP address 192.168.10.10. The FTP server's public IP address cannot be the same as any address in the NAT address pool. After the FTP server is configured, enable the FTP ALG function. This function processes FTP passive packets and converts IP addresses contained in these packets. In the networking requirements, PCs with the internal prefix of 192.168.10.0 and the mask length of 24 can access the Internet, but PCs on the other network segments cannot. To implement this function, use the ACL. Create ACL 3001 and access the ACL view to create an ACL rule named Rule 1. Packets only of the users with the IP prefix 192.168.10.0 and the mask length of 24 can be processed by NAT and access the Internet. After the ACL-based traffic diversion policy is configured, apply it to Interface 2.